So hi everyone, welcome to my channel. In this video, I am going to explain the Archimedes principle in the first part of the video, and in the second part of the video, I am going to explain a few problems based on this principle. Now, according to Archimedes principle, the statement is when a body is completely or partially immersed in a fluid, the fluid exerts an upward force on the body, and this upward force is equal to the weight of the fluid displaced by the body. The upward force exerted by the fluid is called buoyant force. It's called buoyant force. Now, consider we have a vessel containing some fluid. Okay, and suppose the vessel is filled till this level. So this is the level of the liquid, and a body is immersed. So this is the body. Okay, now suppose V is the volume of the body. Volume of the body is V, and immersed volume is Vi. So this is Vi, basically this part, the immersed volume. Okay, now say rho S is the density of the body, S for solid. So this is a solid body immersed in a liquid. So rho S is the density of the body, and rho L is the density of the liquid. Okay, so now the principle states that the upward force, since upward force exerted by the fluid on the body is equal to the weight of the displaced volume of the fluid. Okay, so upward force is equal to weight of displaced volume of fluid. Okay, now this upward force is called the buoyant force. The upward force is called the buoyant force, FB. Okay, now weight of the displaced volume of the fluid. So what is the, see, immersed volume is Vi. So that means Vi volume of liquid is displaced. So weight of the displaced volume of the fluid will be Vi into density of the liquid. Volume into density is mass into weight. This is equal to the weight of the displaced volume of the fluid. Now, Archimedes principle says that this buoyant force is equal to Vi rho L G, immersed volume into density of the liquid. This is rho, this density of the liquid, into G. Okay, now since this body, this solid body is floating, so that means the weight of the body acting in the downward direction and upthrust acting in the upward direction, they are equal. Okay, so now what is the total volume of the body? V. What is the density of the body? Is rho S. So weight of the body, W, will be V rho S into G. Now these two quantities, they must be equal at equilibrium. These two forces must be equal. So at equilibrium, I can write V rho S G is equal to Vi rho L G. So just the G and G cancels out. So we have Vi by V is equal to rho L by rho S. Okay, so this quantity Vi by V, what does it gives? Gives the fraction of immersed volume. Fraction of volume immersed in the liquid. Or fluid. Now, if this is the fraction of volume immersed, now if you are asked to calculate the percentage of volume immersed, then you have to simply multiply this quantity with 100. That it will be equal to rho L by rho S into 100. So this is the expression for fraction of volume immersed. So Titanic surprise. Now let's see what is the Titanic surprise. See, as we know, the Titanic met with the accident because of its collision with an iceberg. So now, what is the problem with the floating iceberg is that we are going to identify now. Now, as we have seen that the fraction which is immersed fraction, it is equal to the density of the object divided by density of the liquid. Okay, density of the floating object divided by density of the liquid. This is the expression we have already obtained. Now, for ice, the density is 917 kg per meter cube. For seawater, the density is 1030 kg per meter cube. Now, if you substitute these values over here, we see that the fraction immersed, it will be 917 divided by 1030. Now, if you divide this, you will get the value 0.89. Okay, so what does that mean? That means around 89% of the ice is immersed and only 11% is above water or above sea level. So what does this mean? See, visible fraction of ice above water surface is only 11%, but it is the unseen 89% below the water that represents the danger to the passing ship, and that was perhaps the cause of the sinking of the Titanic ship. Now suppose we are given this question: a piece of ice is floating in a glass vessel filled with water. Now the question is, how will the level of water in the vessel change when the ice melts? So in this case, let's say m is the mass of the ice. Okay, so weight of ice is mg. Okay, so now if Vi is the immersed volume, then upthrust will be Vi into density of water into G. Okay, now since the ice is floating in water, these two quantities, weight of ice must be equal to the upthrust. So we have mg is equal to Vi, immersed volume, density of water into G. So from this Gg cancels out. So we have Vi is equal to m by rho W, density of water. Now this is the immersed volume. Immersed volume. Okay. Now, if when this m gram of ice melts, when this m amount of ice melts, if V is the volume of water forms, so V volume of water forms by melting of ice of mass m. So that is m is equal to V into rho W. So that gives V is equal to m by rho W. V equal to m by rho W. But m by rho W, it is equal to the immersed volume. So what does that mean? That means the level of water will remain same because the volume has not changed. Okay, so the level remains same. The conclusion is the level remains same. Okay, so this is the final result. So this is another interesting question. An ornament weighing 50 gram in air weighs 46 gram in water. Okay, in air the mass is 50 gram, and when it is immersed in water the mass is 46 gram. So this reduction in mass is due to upthrust. Assuming that some copper is mixed with gold. Okay, in that ornament some copper is mixed with gold to prepare the ornament. Find the amount of copper in it. So the information given is specific gravity of gold is 20, specific gravity of copper is 10. Okay, now let's see how to proceed. So let's say mass of copper in the ornament is m. Okay, now total mass is 50 gram. So mass of gold, it will be 50 minus m. Correct? Specific gravity of each is given. Specific gravity in CJ system, it is numerically equal to density. So volume of copper will be mass by density, so m by 10. Similarly, volume of gold, it will be how much? 50 minus m divided by specific gravity of gold is 20, so this is 20. Okay, so now see upthrust, you know that upthrust is equal to decrease in weight. Upthrust is equal to decrease in weight. So upthrust is upthrust due to this copper part and upthrust due to the gold part. So upthrust due to the copper part, it is VCU, density of water, into G. So this is upthrust due to copper part. Upthrust due to gold part, VAG, density of water, into G. This is equal to decrease in weight. How much is the decrease in weight? 50 minus 46, isn't it? Okay, so now what is VCU? It is m by 10, density of water, GG, all G cancels out, plus VAG, it is 50 minus m divided by 20 is equal to 4. Now density of water, it is known in CGS, it is 1 gram per centimeter cube. Okay, so now if you solve this, you will get m as 30 gram. Okay, so that means mass of, what is m? M is mass of copper. So that is mass of copper in the ornament is 30 gram. So basically using this method, we can check the adulteration in ornaments.